In this video, we're going to look at even and odd functions. We're going to look at the graphical or geometric definition of each of the functions and also an algebraic definition of each. And we're going to use the algebraic definition to look at some examples to determine whether or not a function is even or odd or neither. So first, let's look at some definitions here. So the geometric or graphical definition of each of these types of functions: an even function is symmetric with respect to the y-axis. So that means that for each value on the left side of the y-axis, it's the same value as on the right side of the y-axis. If you look at the graph as a piece of paper and you fold it across the y-axis, each side of the graph will lay on top of each other and match exactly. So let's look at a couple of examples of these. So this is a graph of y equals the absolute value of x. You can see both sides of the y-axis have exact y values, so it's symmetric across the y-axis. And another example. So this graph is your standard parabola, y equals x squared. Again, you can see it's symmetric across the y-axis. If we took that as a piece of paper and folded it right along that y-axis, both sides of the graph would lay right on top of each other. So for the odd graphs, so this graph is probably the most simple odd function, y equals x. So what we mean by symmetry with respect to the origin, we mean that if we rotate one side or the other from the y-axis 180 degrees, we're basically going to lay on top of the other side. So if we take this, say this side, and we move it over here 180 degrees, we would lay on top of each other. So that function is an odd function. Here's another one. So this is a graph of y equals x cubed. Same thing as before. If we take this graph and rotate it 180 degrees around the origin, we're going to lay on top of the other side of the graph. This graph is odd. So these definitions give you some ways to look at a graph and maybe think you know that it's even or odd, but the algebraic definitions will give you a definitive way to determine whether a function is even or odd with no need for the graph. So here are the definitions for an even and an odd function algebraically. So for an even function, you see f of minus x equals f of x. So thinking back to the symmetry of the graph, what this means is that anytime we plug in a negative x, we get the same value that we get when we plug in an x. Thinking about the parabola or the absolute value that we were looking at before, y equals the same value for both 2 and negative 2, for both 1 and negative 1 in the graph. That symmetry links back to this algebraic definition. Looking at an example of this in a graphical form to give you a better idea of how it all links together. Here's a picture basically of what I was just talking about. You can see here that we have a negative x, so here's a graphical picture showing what I was talking about. Here we have a negative x, we have an x. Both of these values, when plugged into the function, result in the same y value. So f of x and f of negative x are the same value. For the definition of odd, we have f of negative x equals negative f of x. So again, thinking back to the symmetry around the origin, anytime that we plug in a negative x into our equation, we're going to get the opposite value of what we had when we plugged in x. So if we plug in x and we get a value of 2, when we plug in negative x, we're going to get a value of negative 2. Here's a graphical representation of this. So again, here we're plugging in a negative x. Here's our value f of x. And when we plug in our negative x value, we get a negative f of x as a result. So how can we use these definitions to determine if a function is odd or even? Well, we can take the function, plug in negative x, see if we get either f of x back or if we get negative f of x back, and then we can easily see whether or not a function is odd or even. So let's look at a few examples. We're going to set f of x equal to x to the fourth plus x squared plus 10. And we want to know, is this function even or odd or neither? So what we're going to do is we're going to take our function and we're going to plug in a negative x. So we'll have f of negative x equals negative x to the fourth plus negative x squared plus 10. So what does this equal? Well, we know when you're taking even exponents, the negative sign is going to go away. So this is just equal to the original function that we had. So this equals x to the fourth plus x squared plus 10. And that equals f of x. So this function is even. Let's look at another example. So let's look at this function, f of x equals x to the fifth minus x to the third. So for this one, let's just write over here what negative f of x equals. So if we multiply through f of x by a negative sign, we're going to get negative x to the fifth plus x to the third. So we'll keep this over here. We're going to look at what the value of f of negative x is, and that's going to equal negative x to the fifth minus negative x to the third. So then if we simplify this a little bit, we're going to have this is equal to negative x to the fifth minus negative x to the third. And then if we take that one step further, we're going to have this is equal to negative x to the fifth plus x to the third. So you can see here the two, so this value that we got for negative f of negative x is the same as this value that we got for negative f of x. So in this case, we have f of negative x equal to negative f of x. So this function is odd. So let's look at one other example. Let's look at f of x equals x squared plus 10 divided by x cubed. So like the example before, let's over here just put what we think negative f of x is equal to. So we're going to do negative f of x, and that's equal to negative x squared minus 10 over x cubed. So now in our original function, let's look at f of minus x, and that is equal to minus x squared plus 10 all over minus x raised to the third power. And then this equals x squared plus 10 over negative x to the third. Now if we look at these two answers, the answer that we got for f of minus x and the answer we got for minus f of x, on first glance they don't look the same, but I think we'll be able to get them to be equal to each other. Let's multiply this by -1 over -1. We can do that. That's the same thing as multiplying by 1. And that's going to equal -x squared minus 10 over x to the third. So now we have this equal to f of -x, this equal to -f of x. They're the same thing. So again, this function is odd. Hope you found this video useful. I will be creating many more videos on different mathematic topics. Thank you for watching.